Okay, now let's go to the next person, Tycho Brahe. Kind of an interesting character. They say he was kind of he would go to bars and he was a brawler. So he got into a fight one time. He broke his nose. After that, he was wearing a fake nose the rest of his life. So what kind of made him famous initially was he observed a new star in the sky, and he wrote a book about it, a little pamphlet about it. He thought that this is interesting because according to the theory back then, God made the stars from the beginning of the universe. He wasn't going to make any more stars. So according to the religious theory, no new stars should be born. They were all born from the beginning. Then all of a sudden you noticed some star, really bright star in the sky during the day, and at night it was really, really bright. So there must be a new star being born. So he wrote about that. Then he was given an island all by himself, Viken, probably close to Denmark, somewhere around there. He did astronomical observations meticulously for the planet's paths. And his goal was to discover a new model of the solar system. He didn't necessarily believe the heliocentric model nor the geocentric model. By the way, the new star he discovered actually wasn't a new star. What was it? Starts with S. Supernova. It was actually a star that was dying and it exploded. And when the star explodes, it's so bright that it might look to you as if it's a new star. Okay? Right now, they call this supernova the Tycho Brahe supernova remnant. Okay? So throughout history, some famous astronomers have observed supernovas, and they have written about that, and and that's become famous. So he made many meticulous observations of the path of planets. So one of the motivations for the astronomers back then, besides trying to explain why planets retrograde and why the Venus and Mercury were close to the sun, they were also trying to come up with a model that best can predict the positions of planets from month to month. The predictability power of a model is very important to that model. Okay? So according to Copernicus, the heliocentric model can predict best where the planets ought to be from month to month. Ptolemy thinks his model can predict the path and location of planets, but is actually wrong. It was weak. Okay? So Brahe makes all these meticulous measurements on planets, and he comes up with his own model. Interestingly, his model is more geocentric than heliocentric. So that's kind of unfortunate for him because he goes down in history as important for making all these measurements, but his model is not correct. So the picture for his model is okay, so you got here Brahe's model of the universe. So you see, you've got the sun at the center of the universe. Sun doesn't move at all. Oh, sorry. I meant the opposite, sorry. The Earth is the center of the universe. Okay? Earth doesn't move at all. So Earth is standing still. The sun is moving around the Earth. So far, it sounds similar to Ptolemy's model, right? Earth is standing still. Moon is going around the Earth. Sun is going around the Earth. Okay? So mainly geocentric. Earth is at the center. The stars are stuck on the celestial sphere. So you see, again, that notion of the celestial sphere is there. Next one. Sun goes around the Earth. So far, exactly equivalent to Ptolemy's model. Here is where it's different. All the planets revolve around the sun. in circular orbits instead of revolving around epicycles. You see, with if you review quickly Ptolemy's model, it was the Earth. Venus was going something like this, right? And then the sun was here, going around the Earth. This is Ptolemy's model. And then Mars was also doing similar, okay? So the planets basically were doing their little epicycle, and they were going around the Earth. The sun wasn't doing an epicycle, it's just going around the Earth, and then all the other planets doing similar. Let's see how this one is different. It's actually a pretty clever model if you look at it. He's got, you see, he's got Mercury going around the sun. But of course, as the sun goes this way, Mercury has to kind of go with it too. Okay, so it's got to do this. You see? And the sun is always at the center. So doesn't that mean that they're also doing epicycles? Backward motions? Yeah. Okay? So it's not that much different than Ptolemy. He's got Venus doing the same thing. He's got Mars doing the same thing. Of course, it looks like something's going to crash into each other. Okay? Then you've got Saturn, Jupiter doing the same thing. After a while, it becomes hard to draw it. Okay? So they're all going around the sun, but the sun is also going around the Earth. Okay? Now, the one interesting thing that you'll observe from this does his model account for retrograde motion? Why planets go back? Yeah. You see? Goes back. 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 Is it correct? No. But at least it accounts for it. Does his model account for why Mercury and Venus are close to the sun, but Mars and Jupiter and Saturn, they can be far from the sun in the sky? Does his model account for that? Watch, it does. You see how Mercury's orbit is like this? The furthest that Mercury can be from the sun is when it's about here. Inferior conjunction. This is a maximum angle from the sun. Then it goes here and here and here and here. Superior conjunction. Same with Venus. Venus is here. Inferior conjunction. When Venus is here, the maximum angle from the sun. Then Venus is here, 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 here. Superior conjunction. So Mercury and Venus can only be in inferior conjunction and superior conjunction. Look at Mars. Look, you see how big he makes Mars's orbit? This is Mars. So when Mars is here, what position is that called? Starts with O. Opposition. So he knows. He's not stupid, you know. He knows that Mars sometimes rises opposite of the sun. So he makes Mars's orbit big enough so that Mars is opposite to the sun. So he accounts for opposition. And then Mars can be, of course, in this position, which is superior conjunction. So it kind of looks like the Copernican model. Not too much different. So as you can see, it's like a mixture of Ptolemy, a mixture of Copernicus. He's able to account for most of the things that we want him to account for. The problem, however, becomes his student. His student comes and works for him, Johannes Kepler, okay? And he tells Kepler, okay, you figure this out to see if this makes sense, okay? So again, there's a lot of cool history behind this. I believe there was some kind of disagreement between them. Kepler came and worked for him in 1600, and he said, can I use all those data that you've collected? And so now I can check to see if your results are good. And then Brahe said, you're not going to use all the data that it took me 20 years of hard labor. You do your own data collecting, and then you figure it out. And then Johannes Kepler goes, okay, whatever. Then, fortunately for Kepler, Brahe dies. Okay? About that year or something, 1600. And then what does Kepler do? Steal his data. Okay? A lot of intriguing stories like that in the history of science, you know. So you got to read books on history of science because there's a lot of history behind these people. It's intriguing, you know. He steals his data, and now he's got 20 years of data. So all he has to do is spend years and years analyzing the data and seeing which model can best fit that data and which model can best predict the positions of planets from month to month to month to month, the predictability.